All right, so on number 9, let's read the directions. It says, for each of these piecewise defined functions below, use the equation to identify and classify any and all discontinuities that may exist in the graph. Justify your responses analytically, and then graph the function to verify your response graphically. So what this means is we need to be able to look at where there is a potential hole or something going on in the graph. This says that x is less than -1, and this says, hey, this is picking back up on the other side of -1. So what we need to do is plug in -1 and check out the y value. So this is the left side of -1. So as x approaches -1 from the left, g of x, and then I'm just literally plugging in -1 into the function, and I get 6. Now this is the right side of -1 because x is bigger than -1. So I'm going to plug in -1 into this function, and then I'm going to see what I get. So as x approaches -1 from the right, g of x is equal to, and it turns out that it's 6. So now the only question is, does it exist when x equals -1? Well, the problem is there's no inequality symbol that includes -1. Both of these would be an open circle. So g of -1 doesn't have a y value. So then that means we're going to have point discontinuity. Since both pieces approach the same y value and g of -1 is not that same y value, then g of x has a point discontinuity at x equals -1. And so if we were to go ahead and graph, this is what your graph would look like. All right, number 10. We need to identify where the potential discontinuity is, and it's going to be at -2 because this is the left side of -2. This is the right side of -2. So we need to figure out what's going on. So on the left side, we're going to plug it in. We get -2 plus 4. That gives me a 2. 2 minus 1 is 1. Now we're going to plug in -2 here. We're going to get, when we plug in -2, these cancel. I get +3 plus 4 is 7. Notice that these y values are not the same. So, excuse me. So since both pieces approach different y values, then h of x has a jump discontinuity. And when I go to graph that, that's exactly what's happening. All right, last one. All right, so if we take a look, we've got potential discontinuity at 0. This is the left side of 0 because it's smaller than 0. This is the right side. So I am going to plug in 0 into this first equation. When I plug in 0, I get -5. Now I'm going to plug in 0 here and also see what I get. I also get -5. We also know that this is equal to. So we know that h of x, or at least h of h of 0 equals -5, then that means it's defined at that spot, so it would be a closed dot. So here is the explanation for that, right? So as since both pieces approach the same y value, and h of 0 equals that same y value, then h of x is continuous at x equals 0. So if I were to graph, then you can see that there's no break in the graph.